Hi viewers, welcome to the course of Analog and Digital Electronics. So we have been learning about the decoders. In our previous classes, we have learned how to design a 2 to 4 decoder and also a 3 to 8 decoder individually using the logic gates. Now we design a 3 to 8 decoder using 2 to 4 decoders. Using 2 to 4 decoders. First, let us analyze that how many 2 to 4 decoders are required to design a 3 to 8 decoder. So 3 to 8 inputs are 3 and outputs are 8. In 2 to 4 we have 2 inputs and 4 outputs. If you take 2 to 4 decoders, 4 plus 4 will become 8. So how many 2 to 4 decoders are required? We require 2 to 4 decoders. We require 2 to 4 decoders. Let us use the simple logic here. Let us use the simple logic of what is called as the enable input. What is called as the enable input. So it will have, this is 2 to 4 decoder, this is 2 to 4 decoder, and this is also 2 to 4 decoder. And 2 to 4 decoder will have how many inputs? 2 inputs. Same inputs you can apply to the other 2 to 4 decoder, A input and B input. And it will produce the outputs as 1, 2, 3, 4. Let us name them as the D0, D1, D2, and D3. And this also produces 4 outputs because it is 2 to 4 decoder. Name them as D4, D5, D6, and D7. Now, where is the logic? The logic is at one instance of time we enable this decoder. That means this decoder will work, and at the other instant this decoder will give the output. Totally it will give 8 outputs. It will give 8 outputs. But for 3 to 8 decoder it needs 3 inputs. Where is the third input? That is our enable input. And this input is called as the enable input. We represent with EN and we call it as the enable input. Enable input. And this enable input is applied as the third input for this upper decoder like this after NOT gate. And to this, without NOT gate, it is connected. Without NOT gate, it is connected. Then let us see the logic. By chance, if enable input is 0, 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 what is happening? Here, how many AND gates we have? 4 AND gates if you remember the logic diagram. So, to each of the AND gate, enable input is connected. If 0 is the enable input, complement of 0 is 1, 1 is connected. This is not affecting the functioning of the upper decoder. It will function as it is. Because to input to AND gate, if you apply 1 as the input, this is called as the enable input. It will enable other inputs to pass to the gate. That itself cannot decide the output. Depending on the other inputs, the output will be different. Depending on the other inputs, how output changes, we have already designed in the 2 to 4 decoders case. Now, if this is the case, 0 is applied to the lower decoder, 2 to 4 decoder. If 0 is applied, what will be the outputs? D4, D5, D6, D7, all are going to be zeros. Because in the internal logic diagram, we have 4 AND gates. To each of the 4 AND gates, a 0 is connected. A 0 is connected here, 0 is connected here, 0 is connected here. Default, in respect of other inputs, output is because 0 is called as the disable input of the AND gate. This topic I told at the time of discussing the logic gates. You can refer to my video on logic gates for this. So 0 is the disable input of the AND gate. It disables other inputs to pass through the gate. So during enable input is 0, the upper decoder will produce outputs from D0, D1, D2, D3 up to D3. Now the second case is if enable input is equal to 1, 1 complement is 0. Now this will be disabled. The upper decoder will be disabled. All outputs are zeros. Now when it is 1, 1 is directly connected to the lower decoder. Now it will produce D4, D5, D6, D7 as the outputs. This is implementation of a 3to8 decoder using 2to4 decoders. The same logic you can apply to implement a 4to16 decoder using two 3to8 decoders. Using two 3to8 decoders. So what will be the change? 3 inputs will be present here and 8 outputs. 3 inputs and 8 outputs, and fourth input will be the enable input. Fourth input will be the enable input. If enable input is 0, this will work. If enable input is 1, lower decoder will work. And that is the logic how to get a 4to16 decoder using the 3to8 decoder. I repeat the working of the circuit. When the enable input is 0, the output of this NOT gate is 1. So 1 is connected as the input of the 2to4 decoder. Then it will function as a 2to4 decoder. It will produce D0, D1, D2, D3 outputs. If 0 is the enable input, 0 is applied as the input for the 2to4 decoder, then this will be not functioning. That means all outputs are zeros. This we should not consider. Second case, when enable input is equal to 1, this will function. It will produce D4, D5, D6, D7. When enable input is 1, the NOT gate